The paper of the day is the SQL Continuous Query Language, Semantic Foundations and Query Execution. SQL is a derivation of the SQL query language developed for running continuous queries over streams of data. The goals of the system are to provide a precise set of language semantics for running such continuum stream workloads. The paper starts by defining precise abstract semantics for continuous queries that cover two data types, streams and relations, and three classes of operators, ones that produce a relation from a stream, one that produces a relation from other relations, and one that produces a stream from a relation. These semantics are defined independent of the underlying implementation. The second portion of this paper defines how SQL instantiates these abstract semantics using existing SQL specifications and some new SQL additions. The paper works through a running example based on road traffic management application to illustrate various aspects of the query language and its implementation. The traffic management application uses variable tolling that adapts the cost of using a road to real-time traffic conditions. It is assumed that the application has knowledge of each vehicle positions and speed. The application then computes tolls in real time and transmits those tolls back to interested parties. In the terminology of streams, this application has a single input stream, the positions and the speeds of vehicles, a single continuous query computing toll, charges for vehicles, and a single output stream returning the tolls to interested parties. Stream and relations are presented using a formal model. A stream S is a possibly finite bag of elements S and T, where S is a tuple belonging to the schema of S and T is a timestamp of the element. In our example application, the input measuring vehicle position and speed is a stream with the sample schema's post-speed string, vehicle ID, speed, and X position. Relation. A relation R is mapping from each time instant to a finite bag of tuples belonging to the schema of R. This definition differs from the standard definition. In the standard definition, relation model, a relation is a set of tuples with no notion of time. In our example applications, relations are derived from continuous query operators. One such example relation is the cost of a toll for a congested segment of road, which is based on the number of vehicles using the road. This can be represented using a relation based on the current number of vehicles using the segment at a particular point in time. Abstract semantics. The abstract semantics define how to write continuous queries and their expected results. There are three different types of operators defined on streams. A stream to relation operator takes a stream S as an input and produces a relation R as an output with the same schema as S. A relation to relation operator takes one or more relation R1 to Rn as the input and produces a relation R as output. A relation to stream operator takes relation R as input and produces a stream S as output with the same relational schema as R. Continuing on abstract semantics, each of these operators can be defined over a particular instant in time, defined as instantaneous relation or stream. There is no stream-to-stream operator because the authors try to keep things framed in the context of existing relational knowledge. Informally, we can think of continuous queries as letting time move forward through the time domain available in the dataset. At a particular point in time, all inputs up to t are processed and continuous query emits any new stream results with this timestamp. Time t advances whenever all input up to time t minus 1 have been processed. This does prevent the issue of clock or timestamp skew, but for defining query semantics, we assume that no such skew exists. Continuous query language, CQL, defines an implementation for the abstract semantics presented. The author's goal is to provide the bulk of operators using relational operators and use new stream and relational operators to convert between streams and relations. The advantage of this approach is to use existing relational foundation as much as possible. Stream to relation operators. All stream to relation operators are based on sliding window of time over a stream of data. The sliding window can be time-based, it can be tuple-based, or it can be partition or defined in new ways depending on the use case. The general idea is to somehow extract a subset of the data based on the current time period and run a query over that subset of data, thereby converting a potential infinite stream to a finite relation. Relation to relation operators. All relation to relation operators are derived from SQL queries by mapping them to an instant in time. Anywhere a traditional relationship is used as a SQL query, a relation can be used in SQL. Relation to stream operators. There are three relation to stream operators in SQL. Operating on different types of streams, inserts, delete, and relations. The insert stream adds a tuple to the stream at a point in time t, and that tuple exists in the relation at time t or at any point in earlier. That is whenever it is within the current sliding window. The delete stream adds a tuple to the stream whenever the tuple is outside the current sliding window of time. Lastly, the relation stream adds a tuple to the stream whenever a tuple is in the relation at exactly the point in time t. Together, these operators create a stream from relation by selecting tuples based on their relation to the current sliding window of time. Looking at the contributions of the paper formalizes streams and relations that are updated over time. And we define an abstract semantics for continuous queries based on 3 black box classes of operators: stream to relation, relation to relation, and relation to stream. Paper defines the concrete language CQL, which instantiates the black boxes in the abstract semantics as discussed earlier. We define syntactic shortcuts and defaults in CQL for convenient and intuitive query formulation, and we point out a few equivalences in the language. Paper illustrates CQL using a hypothetical road traffic management application proposed as a benchmark for data stream systems. They also compare the expressiveness of CQL against related query languages. Paper described the query execution plans and strategies used in the stream system for CQL queries. They focus specifically on operators, inter-operator queues, synapses, and sharing of components among multiple operators and queries.